Greetings all of you. In this video, we will see about types of regulated power supplies. So, if you see with regulated power supplies, there is a linear power supply and switched power supply. With the linear power supplies, we are having two types: series linear regulators and shunt linear regulators. The most commonly used regulator is series linear regulator, as what we are seeing we are using in commercial as well as personal purposes. So when we see with the series linear regulator, first we have to know about line regulator and a load regulator. So regulator is with the input and output power, where the load regulator is the voltage output regulator, constant voltage. So first we will see about line regulator. So the line regulation means from the rectifier or filter the input voltage has been processed, and then it is given to voltage regulator to get the desired output. In that no significant change in output voltage has been noticed. This line regulation is the percentage change in the output voltage for a given change in the input voltage. If there is change in input voltage, it will be replicated in the output. It can be expressed in the unit of percentage per volt. So the formula for line regulation is given as the change in output voltage divided by the actual output voltage divided by the input voltage. So it has been given in percentage. So line regulation is based on input voltage. So we will see one problem for this. So the example problem will be given as when the AC input voltage of a certain power supply changes, the input to the voltage regulator decreases by 5 volt as a result, and the output of the regulator decreases by 0.25 volt. The nominal output is 15 volt. Determine the line regulation in percentage per volt. This is what the problem statement is. In the solution, to find the line regulation, we have to apply the formula. Line regulation is equal to del V out divided by V out into 100 percentage divided by del V in. So the change in output voltage is 0.25 volt, and the actual output voltage is 15 volt. The change in input voltage is 5 volt. So the output is 0.333 percentage per volt. So this is what line regulation is. And when we come for voltage regulation, which is load regulation, we have to consider input voltage with the voltage regulator. Next to that, we can have increasing or decreasing load based on the service we are connected. Okay. So based on that, we can regulate the load. So load regulation means it is the percentage change in output voltage for a given change in load current. We may change the load current to get the desired output voltage. So one way to express load regulation is as percentage change in output voltage from no load to full load condition. So the formula has been given as load regulation is equal to VNL minus VFL, that is no load voltage minus full load voltage divided by full load voltage into 100 percentage. We can see this with an example. So the example problem statement has been given as a certain voltage regulator has a 12 volt output when there is no load. So when there is a full load, the output voltage is 11.9 volt. Express the voltage regulation as a percentage change from no load to full load. The solution has to use the formula load regulation equal to no load voltage minus full load voltage divided by full load voltage into 100 percentage. So 12 minus 11.9 divided by 11.9 into 100, which is 84 percentage. So this is what load regulation is. So next to that, we have to see series voltage regulator. So the series voltage regulator is having a reference voltage, control element, sample circuit with error detector. So it is having a feedback element. Okay, so it can be done with the op amp also. So in the series voltage regulator, the control element is a pass transistor in series with the load between the input and the output, as what given here in the figure. Over that, the output sample circuit senses a change in output voltage, and this has been detected as error with error detector, which compares the sample voltage with the reference voltage and causes the control element to compensate in order to maintain a constant output voltage through which the regulation has been achieved. So the resistive voltage divider senses any change in the output voltage. Op amp can also be used. Op amp circuit amplify the difference voltage, there is error voltage between the reference and sensitive values. This amplified difference voltage is applied to the transistor Q1 to make the load voltage equal to the reference. So here it is given with the block diagram. Here a clear circuit diagram has been given. So the series voltage regulator is having a regulation based on the resistors and op amp transistor connected. So the output series voltage regulator is giving the output voltage as V out is equal to 1 plus R2 by R3 into V reference, where R2, R3 are the sample circuit resistors connected with the op amp to sense the change in output voltage. So these are the three basic types: load regulation, line regulation, and series voltage regulator. The next video we will see about IC regulators, IC based voltage regulator. Thank you.